Welcome to myprojectbazaar.com. Let's discuss about the product. Our product is texture analysis based segmentation and classification of oral cancer lesions in color images using ANN. Features derived from gray level co-occurrence matrix, that is GLCM, and gray level run length matrix, that is GLRLM, are widely used for image characterization based on texture analysis. In this paper, we propose the application of suitability selected textures, discriminating features for classification of oral cancer lesions in digital camera images into 6 groups. Backpropagation based artificial neural networks is used to compare and validate the performance of different feature sets. The classification accuracy is observed to improve with combination of GLCM and GLRLM and intensity based first order features. Further improvement in accuracy is obtained by application of feature selection using box plot analysis. A set of 61 features is formulated and applied on 192 sections of images taken from 16 patients. Such a classification of malignancies is helpful in prognosis and treatment of oral cancer, which is the most common form of cancer in India. Image characterization using texture analysis is quite relevant in such cases where the surface under consideration forms sufficient number of distinguishable patterns which may or may not be recognized by a human observer. Needless to say, statistical approaches, the computational methods, are fare better than human capabilities in deriving a conclusion based on analysis of such patterns. In this work, we propose the use of popular texture analysis methods. The objective of current study is to select a reduced set of features which can clearly distinguish between different group of malignancy caused by cornicoma of different areas or oral cavity. The novelty which we are introducing is the simplicity of the input. Earlier attempts have been the use of histopathological and microscopic images. Color images were also used with color-based features. Here, we propose the use of texture and run length features of camera images. Although many systems are considered abnormal, there is an apparent scarcity of system performing within class classification of malignant cases. Such systems are quite useful in prognosis part. With help of such a system, doctor can easily identify the class of malignancy, and this will help him in deciding the right treatment path. Such a system will also be useful in later part of treatment, where he can analyze the progress in patient's condition with treatment by comparing images collected at different storage treatment. Here we can see the block diagram represents the system flow within of our work. So in this work you can see initially we have taken the images, that is oral cancer images, as a database. So collection of images that includes affected and non-affected, that means malignancies or non-malignancies. That means the database includes malignancy images and also non-malignancy images. Our goal is to classify correctly with malignancy or non-malignancy. For this classification, we are using texture segmentation algorithms with combination of GLCM and GLRM. And depending on the segmentation accuracy, we have to use the classification method. For classification, we are using a classifier. In paper, they have used ANN classifier, but as an enhancement of this work, we are implementing SVM classifier, that means support vector machine. So by using support vector machine, we are classifying the result. That means we are classifying the segmented image whether it is malignancy or non-malignancy by using SVM classifier. Basically, SVM classifier gives better results for biomedical images. So we can see our classification method is here. We are replacing existing with our proposed SVM classification method. Let's see the running procedure of our product. Here the directory shows what are the files included in our project. So the .m files indicates that is a program file by MATLAB programming. So that .mat programs or the matrix files includes matrix values used during this program. The .figure file is represents guide design. So we can see while we are running that corresponding M file, it will open corresponding .figure file, that is the guide design. So here select our main file and select run. So while you are selecting run the button, you can see in command window the file which you have selected shows in the name. So we have selected the file regarding to this panel. So while we are pressing that button regarding to for example, if we are pressing saliency.m file, that will open saliency guide design file. So this is called a guide design file. Here there are number of push buttons are located. So each push button is corresponding codes having in its backend. Every button is processing with a backend code. While we are pressing any button, that will call the process which we have located in the guide framework and with its corresponding .m file. So here you can see, as we already discussed, our enhanced method SVM is noted here. So this all locates and indicates a segmentation and classification method. So each button represents what are the process we are going to do, and the yellow color hints it shows so what's the process, what's the button doing the process. Okay, so for example, if I am pressing that input button, so here you can see in that click to select an input image. So I am selecting input image from it's going to a directory and I am selecting an image. Here you can see this is the normal image. I am selecting this normal image for the process. Here you can see the image displayed here. This is the backend frame is called axis. In the axis the image is displaying and I am extracting ROI. In that ROI extraction the image is resized into particular size. For example, here we resized into 512 into 512. That means 512 rows and 512 columns of pixels. And then we are doing pre-processing. In pre-processing, noise removal is done. So after pre-processing, then I am coming to main frame. So this is the grayscale conversion of the original image. Our given input image is based on RGB and we are processing that into grayscale. And I am taking from this entropy, our texture segmentation process starts. Up to here, outline boundary regions, the texture segmentation process continues. So after taking entropy, I am pressing rough mask, and you can see the difference between rough mask, that intensity based pixels are covered in white, other remaining backgrounds are neglected, that means in 0. And bottom structure, smoothen region, segment structure. We can see the image is processed at two types, based on object and based on background. So here you can see the object was segmented and we didn't get any affected region here. So again we are separating, doing the same process for backend. So in every process you can see the grouping is enlarged. That means that covering the region. So these are the final segmented region. Here it didn't get any affected region. Here see outline boundary regions. These are the separated two objects and background, but here there is no affected regions. So here there is an example segmentation how other processes are doing. So and then identification. The identification is processed by the classifier, as we told SVM classifier. In backend SVM classifier is classifying whether it is a normal or affected. Here the given image is based on normal, hence the result shows the image given is a normal. Thank you.